Hey guys, welcome to the first video in the series Structural Concepts and Design. The objective of this video is to look at the definition of a load. We're going to be looking at the typical loads in a structure and their corresponding standards, and then we're going to be looking at the classification of loads. Now, up until this point in your degree, you probably would have done a structural mechanics course where we say have a beam or a column subject to some type of axial or UDL or point loading, and normally that's given to us in the question. We have, say, a 14 kilonewton per meter on a 5 meter beam, for example. So what this part of the course looks at, the objective of this entire course, is now to work out the magnitudes of those loads. So where do we actually get those loadings from? Where did we get that 14 kilonewtons per meter from? So the first thing we're going to do is just define a load. A load / action is a force that acts on a structure. So point loads, UDLs, all that type of stuff we've seen before. Now we're going to be looking at the typical loads and their corresponding standards. So the first load is the dead load, which we sometimes summarize as capital G. Now, the dead load is normally just the self-weight of a member, so say the weight of a beam or the weight of a column. And we also have something called the superimposed dead load. So example of that would be carpet. So say you've got a floor slab and you've got carpet on there. We call that, it's not the actual dead load of the slab, but it's a dead load, it's not moving. So we give that another title called superimposed dead load, which is all part of dead load, okay? Now, if we look at a simple structure like this, a house, you can see we have walls or columns, we have beams, we have slabs and roofs. We call this the dead load. It's the load which isn't moving anywhere, it's dead. Okay, and then we also have something like carpet, which we call a superimposed dead load. And the entire dead load is just the sum of the self-weight and superimposed dead load. Okay, so there's a schematic of what some dead loads would be in an ordinary structure. Now, the code for this is AS 1170.1, Part 1, permanent actions, permanent, imposed, and other actions. So I've got that over here. AS 1170.1, 2002, Part 1, permanent, imposed, and other actions. Okay. Now, we also have the second type of loading, which is known as the live load. Now, we summarize the live load as Q. And the live load is things like people and furniture. Okay, so it's not as consistent as the dead load. The weight of a beam is always going to be the weight of a beam, but people, they move around a structure. Okay, so if we look at our house again, something like a person, some furniture, a cat, it's subject to moving. Okay, so we call that live load, which is sometimes summarized as capital Q. That's also found in the same standard, AS 1170.1, Part 1, permanent actions, imposed, and other actions. Okay, so this code here comprises the standards and the procedure for finding both dead and live loading. The third type of loading is wind loading. Okay, so here's our typical structure, our house, and we're getting some type of wind blowing on our structure, and the code is going to allow us to work out the profile of the force which is acting on our structure. This is found in AS 1170.2, Part 2, which is wind loads. So if I show you that, AS 1170.2, 2002, we have structural design actions, Part 2, wind actions. Okay, so it's a whole long procedure to allow us to work out the wind loads. This is obviously just a very brief introduction video. In the later topics, we're actually going to be using the codes to work all these things out. The next type of loading we have is snow loading. So obviously this is only going to be relevant in some regions of Australia. But just to show you, we're going to have, say, snow on our roof, which is going to impose a vertical load. So that's snow loads. That's found in AS 1170.3, Part 3, which is snow and ice actions. So if I show you that, AS 1170.3, 2003, we have structural design actions, Part 3, snow and ice actions. And the last type of loading is earthquake loads. Okay, so we have our structure. We're going to get some type of ground acceleration here, which is going to cause some type of base shear. It's going to shear the ground over there, which is going to impose a earthquake loading on our structure. This is found in AS 1170.4, earthquake actions in Australia. So if I show you that, AS 1170.4, 2007, we have Part 4, earthquake actions in Australia. Okay, so those are the basic types of loading we're going to have in our structure: dead, live, wind, snow, and earthquake. The last thing we're going to be doing in this video is just classifying some of these loads. This point isn't really that important, but it's nice to know. So the first type of classification is static versus dynamic. So static is a consistent load, whereas a dynamic is a time dependence load. So if we graph P, which is load against time, a static load is just, it's consistent, it's remaining the same, whereas dynamic is changing with time. So examples of that, the self-weight, the beams or slabs, they're not going to change with time, it's consistent. But a wind, you could have a strong wind coming and then no wind. An earthquake, you're not always going to have earthquake loading. An earthquake appears at one stage in time, and therefore it's dynamic. The second type of classification we like to refer to is vertical/gravity or lateral loading. So vertical loading or gravity is just pointing down, it's vertical, and lateral is more horizontal. Okay, so vertical, for example, is dead loading, or gravity, or lateral loading is, for example, wind load. It's going laterally, or an earthquake, it's horizontal to the structure. Okay, so just keep in mind throughout these videos, I might be referring to some of these terms. They're just jargon for this unit of study. Anyway, guys, once again, this is just a very brief introduction to what's going to be coming up in the upcoming videos. Once again, the whole point of this unit of study is to now work out the magnitudes of the loads which we've been seeing in topics like structural mechanics and that type of stuff. Anyway, guys, hope that helps, and we'll see you in the next video.
Cut study time with concise video summaries by top students. Visit spoonfeedme.com to view more free videos in this course and hundreds of others.